Welcome to Olympiad Math for Year 4. This is Lesson 5, we'll learn cuboids and cubes. Today, we need to master methods for finding the perimeter, surface area, and volume of more complex cuboids and cubes, then try flexibly using the properties of cuboids and cubes, as well as the formulas for surface area and volume. Please pause the video and think and fill in. 1. A cuboid has 6 faces, 8 vertices, and 12 edges. 2. If a cuboid has length A, width B, and height H, the formula for surface area is S equals 2 times the sum of AB, AH, BH. The formula for volume is V equals A times B times H. 3. When the length, width, and height of a cuboid are all equal, it becomes a cube. So we say that a cube is a special kind of cuboid, and all 6 of its faces are squares. 4. If a cube has side length A, the formula for surface area is S equals 6 times A squared. V equals A cubed. Cuboids are also called rectangular prisms in some textbooks. They are 3D shapes with 6 rectangular faces. Example 1. A carton with a length of 8 decimeters, width of 5 decimeters, and height of 2 decimeters is tied up with 3 pieces of string, as shown in the diagram. Each knot requires 1 decimeter of string. What is the minimum total length of the 3 strings? There are 2 vertical strings. Each of these includes twice the width, twice the height, and 1 decimeter for the knot. The horizontal string includes twice the length, twice the height, and 1 decimeter for the knot. The answer is the total minimum length of the 3 strings is 51 decimeters. Example 2. The figure below is made by assembling 18 small cubes, each with an edge length of 1 centimeter. Find the surface area of the solid. To find the surface area of this cuboid, one way is to count and add up the area of each face one by one. However, this method is too time-consuming. If we observe carefully, we can see that the top and bottom, left and right, front and back, have equal areas respectively. So we can calculate it as 2 times the sum of 9 plus 8 plus 7 equals 48 square centimeters. The answer is the surface area of the solid is 48 square centimeters. Example 3. The figure on the right is built using 16 small cubes, each with an edge length of 3 centimeters. What is its surface area in square centimeters? We will analyze the 6 faces of the figure: top, bottom, front, back, left, and right. Top and bottom faces have 9 times 2 equals 18 faces. Front and back faces have 7 times 2 equals 14 faces. Left and right faces have 8 times 2 plus 2 equals 18 faces. So the total number of visible square faces is 18 plus 14 plus 18 equals 50 square faces. Each face is a square of side 3 centimeters. So the area of one face is 3 times 3 equals 9 square centimeters. Therefore, the total surface area is 9 times 50 equals 450 square centimeters. Example 4. A cube with an edge length of 4 centimeters is painted red on all its outer surfaces. It is then cut into smaller cubes, each with an edge length of 1 centimeter. How many of the small cubes have no red paint on any of their faces? To solve this, we need to find the total number of small cubes after cutting, and subtract the number of small cubes that have at least one face painted red. Step 1. Calculate total number of small cubes. 4 times 4 times 4 equals 64. Step 2. We can have 2 methods to count the number of cubes with at least one red face. Method 1. First, calculate the total number of painted faces. 4 times 4 times 6 equals 96 faces. Since each of the 12 edges has 4 small cubes that are double counted, subtract 4 times 12 equals 48 times. However, each of the 8 corner cubes was subtracted once too many in this process, so we add back 8 times. Method 2, approaching from the perspective of overcounting. First, calculate the total number of painted faces as method 1 and get 96 faces. Each corner cube was counted 3 times, so we subtract the 2 extra counts per cube. 2 times 8 equals 16 times. Each edge has 2 middle cubes that were counted twice, so subtract 1 extra count per cube. 1 times 2 times 12 equals 24 times. Both methods can calculate the total number of cubes with at least one red face is 56. Step 3, cubes with no paint, 64 minus 56 equals 8. The answer is there are 8 small cubes with no red paint on any face. If the question asks how many cubes have 3, 2, 1, or 0 red faces, we can solve it using these observations. Cubes with 3 red faces are at the 8 corners. Cubes with 2 red faces are along the 12 edges, excluding the corners. Cubes with 1 red face are at the centers of the 6 faces. Cubes with no red faces are the inner cubes, completely surrounded. Example 5, a cuboid has equal height and width. If its length is reduced by 2.5 centimeters, it becomes a cube with a surface area of 150 square centimeters. How many times the width is the length of the original cuboid? A cube has 6 identical square faces. So, the area of each face is 150 divided by 6 equals 25 square centimeters. This means the edge length of the cube is the square root of 25 equals 5 centimeters. Since the cube was formed by shortening the length of the cuboid by 2.5 centimeters, the original length of the cuboid is 5 plus 2.5 equals 7.5 centimeters. Now, we compare the cuboid's length to its width, and we can find the answer is the length of the cuboid is 1.5 times its width. Example 6, a cuboid has 2-digit integer values for its length, width, and height. The length is the largest, the height is the smallest, and the sum of one length, one width, and one height is an even number. The volume of the cuboid is one of the following 4 numbers: 8735, 6864, 8967, 7853. Find the length, width, and height of the cuboid. The sum of the cuboid's length, width, and height is even. This means there are 2 possible cases: all 3 numbers are even, or 2 of the numbers are odd and 1 is even. In either case, the product that is the volume must be an even number. So the cuboid's volume must be 6864. Then we decompose it into prime factors, and we can group the factors into 4 possible combinations. Based on this, the possible combinations for the cuboid's length, width, and height are: 1 length 33 cm, width 16 cm, height 13 cm, 2 length 39 cm, width 16 cm, height 11 cm, 3 length 26 cm, width 22 cm, height 12 cm, 4 length 48 cm, width 13 cm, height 11 cm. Example 7, as shown in the figure, a cube has an edge length of 4 cm. A smaller cube with an edge length of 1 cm is removed from the center of each of the 6 faces: top, bottom, front, back, left, and right. What is the surface area of the resulting shape? The large cube has 6 faces. Since each face has a square hole in the center, where a small cube is removed, we must subtract the area of the small square from each face. In addition, each small cube that is removed contributes to the total surface area. Because the large cube's edge length is 4 cm and each small cube has an edge length of 1 cm, the small cubes do not connect to each other, so each small cube contributes 5 faces to the total surface area. Here is the step-by-step solution. Area of each face after cutting out the hole is 4 times 4 minus 1 times 1 equals 15 square centimeters. Total area of all 6 faces after cutting is 15 times 6 equals 90 square centimeters. Surface area of each small cube, 5 visible faces, is 5 square centimeters. Total surface area from 6 small cubes is 5 times 6 equals 30 square centimeters. Finally, we can find the answer is the surface area of the resulting shape is 120 square centimeters. Here are the practice problems for today. Thank you for watching and hope you enjoy your math today.